section 8.3 in the Introduction to Electronics by Al Gates book, which has to do with simplifying complex circuits with series and parallel arrangements. So I'm going to attempt to show you the way that I like to do that, in the way that I found to be extremely useful, both in circuits that I have designed and problems that you'll run into later in the quarter. And so, as you can see here, we have the problem from section 8.3 of the book. Now, I just want to show you here what happens with the voltages. And I want to point out a few things. First of all, we have a 24 volt voltage source here. This is the positive terminal of the battery. And right here we have the negative terminal of the battery. And we have a ground right here, which will be the lowest part of the circuit. The positive terminal of the battery is in series with the 1K ohm resistor, which is then in series with a whole mess of resistors, which is then in series with the 270 ohm resistor. Now I want to show you that this is actually 3 voltage drops, essentially. Okay, so right here, I'm in multisim. I'm using this 1.4 volt probe, the measurement probe. Right here we have 24 volts. So far so good. Then we have a 1K ohm resistor, and that apparently dropped about 16 volts, because 24 minus 16 equals about 8. Now, across this entire branch, you're going to see that we drop 4.41 volts. Now, if we measure it here, it's 4.41. And if we measure it here, it's 4.41. But what I want to point out is that these two resistors are in series with each other, and these two resistors are in series with each other. And these count as one equivalent resistance, which we see in this step. Now, I want to show you that the voltage drop here at 7.67 is going to go to 5.43, so that's about 2 volts. And then it goes here, so that's about a 4 volt drop. I'm sorry, a 3 volt drop. Now the volt across that is also 3 volts. Now the drop across this is also 3 volts. Now that's because the circuit, because these are in series, the circuit is seeing these as one resistor. This is one resistor, and this as one resistor. So it's seeing these as 3 resistors in parallel, which counts as 1 voltage drop, because a parallel circuit is a current divider, and voltage is constant in a parallel circuit. And I'm going to demonstrate that over here, that these are all 1 voltage drop. We have 24 volts on the positive terminal, a 1K ohm resistor, which is going to drop it to 7.63 volts, and then, oh, what do you know? There's that 4.41 volt drop again. 4.42, 4.42, 4.42. Why? Because voltage is constant in a parallel circuit. So, that would seem to me that this is seeing this as all one resistor. The circuit is, right? Since it is counting these all as 1 voltage drop, that means that we have basically 3 resistors in series, which we are going to see here in step 3 of simplifying the circuit. Well, let's look at this again. Now we have 3 equivalent resistances, and how I got 197 ohms for those 3 branches was you take 1 over this resistance plus 1 over this resistance plus 1 over this resistance. And the whole quantity, that whole quantity will give you 197 ohms, which I am going to show. I'm showing you the simplification process, but then I'm going to show you how you can very simply calculate it in Microsoft Office Excel, which is basically a graphing calculator that is very easy to use for these circuit applications. But now back to our voltage drops. We have the 24 volt positive terminal of the battery. Our 1K ohm resistor still gives us that 16 volt drop to about 8 volts. And we're going to drop again to about 4.42 because all those branches were seen as 1 voltage drop. There we go. And then just as in the first one, this 270 ohm is going to drop us from 4.5 volts to 0 volts. Now let's see how that's all the same. 24 volts, 7.67, 4.42, 0. 24 volts, 7.64 volts, 4.42, 0. In step 3, we have 24 volts, 7.64, 4.4, 0. And then the final step, whoops, I kind of screwed that up. 296.